name is Henry Zhang. I want to show is the OPNFV demo. The first slide I want to talk to you what is OPNFV. OPNFV want to provide a common platform for NFV developers. It can be split into many modules. The first is network virtualization control and storage virtualization control and compute virtualization control. And each module we can use open source software as a stack. And in network virtualization control, we can use ONOS and Open Daylight as an option. And the storage, we use SAFE. And in compute virtualization, we use KVM. And OpenStack is the orchestrator of these modules. In infrastructure, we use open source operating system such as CentOS, Ubuntu, and OpenSUSE. And the physical machine, we can use Intel x86. So let's continue to talk about why we use OPNFV. In traditional network, we use the architecture of network device is vertical. There are various kinds of hardware in our network, and it's hard to reuse and it's expensive. So we want to change this architecture from vertical to hierarchical. And if you use this architecture, all systems share resource pool, and one hardware platform can run multi-system, reducing hardware number and saving energy, decoupling the hardware and the software. It can save the cost, and it also can provide the ability to plug in as open source software. So it can provide the standard northbound API. It's easy for the app to adapt it. And then, based on the centralized control, the business can be deployed automatically. Yeah. And let me introduce what we have done in ONOS FW project. We use the Compass as an installer to deploy the NFV environment automatically. It can be use only one command, which costs only 2 hours. So if we deploy the large scale of NFV environment, it is fast. And if we only deploy ONOS, it will cost 20 minutes. It's also very short. And after the deployment, the whole environment will like this. And in ONOS FW, we provide the feature of layer 2 feature in the traffic in the same subnet, and layer 3 feature in the traffic between different subnets, and the service function chaining and host live migration. The level 1 we want to demo is complete layer 2 and layer 3 network service. So here are 2 compute nodes, and in each compute node we have Linux bridge named brint, and each bridge have 2 ports. This is a tunnel port, and this is an external port. The tunnel port is used to set VXLAN between compute nodes, and the external port is used to access the internet. So from here we can see different color in VMs. So different color means different tenant. The layer 2 feature means if you use VM1, you can access VM2 in the same subnet, and the traffic is like this. The traffic is passing from the VXLAN to the VM2, and the layer 3 feature means if you use VM1, you can access the internet. And after the administrator assign a floating IP to a VM1, VM1 can get the right to access the internet. And the VM live migration is the second lab. So if user is accessing the VM1, and the administrator will migrate the VM1 from the computer node 1 to the computer node 2, and it will be some operation on OpenStack, but the user will not be aware of. the host live migration. The network is still goes well. The service function chaining is just like this. So if you there are some service function just like firewall or DPI. So if you use VM as a service function, you can build a service function chain on OpenStack quickly, and then ONOS get the info from the chain of the chain, and then it will download some flow rules on open-way switch. The OAS will introduce the traffic into the chain, so you can build your business and service function chain fast. Here is the high performance of ONOS. We tested in several cases. One is a number of ONOS can manage the OAS nodes. When we use a 3-node with no link, so this scenario we are testing the open flow session of OAS. In this scenario, the OAS can reach to 3,000. And the 3-node with link, we are testing the testing with some business app. So the number will reach to 1,200. And this scenario, we are testing the OVS links. We use a full mesh topology. So the full mesh means one OVS will connect to each other devices. And in this scenario, the links can go to 3,000. And if the node still goes up, the link will vibrate. And here is a high viability of the ONOS. So here is a 3-instance cluster, and each one master the same number of switches. So we shut down the second controller, and the switch which mastered by the second controller originally will be took over by other controllers. So in this picture, we can see the third controller take over it. And when offline node recovery, we can use a load balance command to make the switch number be equalized. So the picture can go to the original view. That's all. Thank you.